We're now going to take a brief look at probability. So first, what exactly is probability? A probability just describes how likely something is to occur. What's the chance of something actually occurring? And this is going to be a number between 0 and 1. The closer you are to 1, the more likely your event is to happen, and the closer you are to 0, the less likely you are to happen. So before we actually look at calculating probabilities, let's define some notation. When discussing probabilities, we'll use this thing P of A, and this is the probability of A. And the A can be whatever it is that you happen to be talking about. If you're rolling a dice and you want to see the probability of rolling a 1, you would say P of 1. If you are drawing cards and you want to know the probability of drawing a king, you would write P of king. And there are two very important probabilities. A probability of 1 means your event is certain to occur. It's absolutely going to happen without a doubt. What's the chance that Thanksgiving will be on a Thursday this year? 1. We know it's going to be on a Thursday. And then a probability of 0 means you're impossible to occur. It means this is never going to happen regardless. What's the chance that Thanksgiving is on a Wednesday this year? 0. Now that we have a little bit of understanding about probability, let's look at assigning probability. And there's going to be two different ways to assign probability. The first thing is you look at the number of favorable outcomes over the number of total outcomes. If we are flipping a coin and we want to know the probability that we get a heads, flipping a single coin, there's one way to get a heads, but two possible outcomes, either heads or tails. The second way, we look at the frequency of an event divided by the total number of observations. So these two types of probabilities seem very, very similar, and a lot of times they can be confused, but there is a difference. My first example, I had that the probability of flipping a heads is 1/2, but using the second type of probability, I can't actually determine that. Instead, this second type is an experiment. If I were to flip a coin and I get heads, tails, 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 heads, tails, heads, and I wanted to know the probability that I get a heads, well, this time it would be 3 out of 7, which isn't exactly 1/2. So we do have this thing that this second one is purely by experiment. It's not these set probabilities. However, we do have something known as the law of large numbers. It says the more and more times I do this, the closer it's going to be to this number up here. I flipped this coin 7 times. If I were to flip it 100, I would probably be closer to 1/2. 1,000, even closer to 1/2. 5,000, even closer to 1/2. The more times I do it, the closer I will get to the theoretical possibility. So now let's look at actually calculating some basic probabilities. Let's consider that I want to roll a dice, and I want to find the probability of rolling either a 1 or a 2. Well, this is going to be a standard dice, so there's 6 possible outcomes. And how many are favorable? Well, only 2, getting a 1 or a 2. So the probability is 1/3. Another example, if we have a deck of cards and we're going to draw a card at random, we want to know the chance that we draw a king. Well, we know there are 4 kings in a deck and a total of 52 cards. So this is going to be 1 out of 13, and that's our probability. Let's do one more example. As our last example, let's suppose we have a random sample of 200 students. Out of that, 75 are freshmen. So now what's the probability that if we select a random student, they will be a freshman? Well, 75 freshmen out of a total of 200, which gives me 3/8. So our first two were theoretical probabilities, my first type of assigning probability. This one is experimental, the second type of assigning probabilities.